Hey YouTube. So currently I'm taking a couple of different 53181A frequency counters, and one is basically one I've kept as a parts donor unit because the most common failure mode with these is the fan gets jammed because of dust, it dies, and then the power supply shuts down because it overheated and caps died, and then the whole unit just won't turn on because, bad power supply. You need to fix the power supply to bring it back or replace. Anyway, I encountered this before, like in various HPAK gear. There are these little rubber bumpers. Sorry, I turned away from the camera for a sec when I spoke, and I'm not using my mic right now. There are these little rubber bumpers in a lot of this style of HPAK gear. That's HPAK, Hewlett-Packard Agilent Keysight. And these, I'm now leaning towards considering them always replace on site no matter how good they seem. Because I've seen how sometimes they can turn into this horrific, ugly, plasticized fluid that gets over everything. It's an absolute mess to clean up. So yeah. And I'll show you on this one. This one was all gray. It hadn't darkened, so it looked good. And then I went to touch it, and it felt... I'm not going to touch it with my hand again because it got all over me. You see that? That right there? It's actually liquefied inside of this rubber bumper. It's already liquid. So this is a giant black liquefied plasticized rubber pus pimple just waiting to pop. And it will eventually just eat its way through over the course of time, humidity, and thermal cycles. And then it'll spill out this ugly, nasty black gunk that will just get everywhere, maybe start dripping out of the unit, and it's just a mess. So yeah, I just wanted to spread awareness of this. If you're working on HPAC gear and you see this, just replace it. You don't have to get this exact thing. There's a billion different options for cheap, stick-on little rubber bumpers. I have a bunch of different sizes that I got at a cow lab auction in Ohio, and then others that I've since ordered for different size options. So yeah, we'll just I'm going to very carefully see if we can remove this without popping it. Okay, so we got the adhesive to fail. That's fine. Such a little thing, so much mess. I'm going to pause to readjust this so you don't have to endure the horrible creaking sound of my lock line camera stand. Yeah, it's this one. So, like I said, this is for a customer who's buying a counter from me. I could have just sent them this one. It's working as is, but this had a it was labeled as a 5 gigahertz module. It's a 12.4. It's very sought after, hard to find. It's why I bought this, to harvest that module. But its otherwise working, and it has an option 10 high stability time base. And the customer had bought something else from me and was looking for one of these. So, yeah. But the reason I'm not just selling this as it is because it had that time base. It causes two issues that could be an issue for that customer later. One, the hole where the 5 gigahertz / 12.4 gigahertz module is sized for an N connector instead of a BNC connector. So I can't just harvest a BNC plug from another frequency counter and pop it in here and seal it up. So there's aesthetic issues. But also, because it had this 5 gigahertz module, there's software, well, basically a few bit changes in the EEPROM that tell it to expect a 5 gigahertz module in channel 3 and limit it to that. And then I don't know where to point at it, but somewhere on the back of here there's a 0 ohm shorting resistor. And that means if my customer later on wanted to get the very common 3 gigahertz module for here, or any of the aftermarket ones that still have BNC connectors, and all the aftermarket ones that I know of, most of the aftermarket ones that I know of are sized to plug through a BNC sized hole, because that's what the majority of this era of counter have. So if I sent my customer this, they would be option limited in the future if they ever wanted to upgrade and get that. I think I kept saying channel 3 because of the other ones have multiple others. Channel 2 in this case. So that's why we're doing this Frankenstein operation to combine 2 meters into one more ideal meter. But I digress. So with this, the purpose of the bumper is something it's useful to know when selecting a replacement. It's basically just as a guarantee that nothing on the circuit board, like if the case flexes, the case can never contact the board and possibly short something out. And also just as a little bit of vibration dampening. Yeah. I'm trying not to hold this too tight because I don't want to pop it. So this isn't a perfect match in terms of height, but it is close enough that it's not a problem. The other option would be something larger like this. That's actually a little taller, but it's much larger, so I'd have to do surgery on this, and yeah. It's fine. You can buy sheets of these by the 100 for a few bucks off AliExpress. And let's get a second one, and I'll just swap that one right now, because that one's more liquefied and it's closer to coming and splurt and make a mess. Alright, pause again to adjust the lock line. And then Here we have our little area for the bumper. We're just going to clean that off. No really special precautions are needed. Like, I could just use an alcohol pad, but I have anhydrous alcohol here. So let's just give that a little bit of a scrub. No major contaminants. We just want it clean for the adhesive to have a good bonding surface. Sure. These are kind of stubborn to peel off. They have a peel here, but I found I get much better adhesive results when I remove that secondary layer. And I'm just pressing gently while giving it a bit of back and forth rotation, counter rotation. No big deal. And that's it. Now you have a replacement bumper, and you're good for presumably forever for that issue. This one is a little more sensitive because it's way closer to popping, and I don't want that. And you can see this here. Yeah, it's much more jellified. So let's get under it, press gently, wiggle, abort, press gently, wiggle, abort, and just repeat. Be patient. We don't want to catch on something, apply a lot of force, and then have it give way and scrape across and like break off an SMD diode or capacitor and have to solder that back on and then test like, did we harm it in the process? It's best to just take your time, be gentle. Something else I could do is use hot air. I'm kind of leery of that because I'm wondering if it would like literally liquefy as I started to warm it up. And what I'm doing when I'm stopping is I'm feeling this catch on areas of the board, which could be just the rays of a trace. And then I stop, pull back, wiggle to get off of that, because I don't want to apply pressure there. I don't want to potentially like damage the bonding between a trace and the rest of the fiberglass board, or fiberglass and epoxy board, resin, whatever. FR4, I think. Careful. Used dental tools off eBay are great for electronics. So this one, the bonding of the adhesive is basically more solid. So we're going to have cleanup afterwards. I think at this point we want to try... No, we'll spend a little more time on this. Feel free to skip ahead. Oh, here we go. I could just rip it off at this point. What I'm doing is applying mild upward pressure, and I'm trying to get as much of it to peel off as a whole as I can, so I have as little cleanup as possible. So yeah, it's all gooey. Fortunately, this one didn't pop. It looks like it's kind of evenly gooified, but not liquefied inside. And it looks like this was a different version. There's an intermediate adhesive pad that's on top of the board. That's what I was feeling. You. Okay. I think we're at the point now that we can start scrubbing with a Q-tip and some alcohol. And on consumables, this is kind of a a minor aside of a lesson. Don't be like penny wise, pound foolish with your consumables. Swap them often. And then in cases like this, I never feel like I need to use both sides because I don't want to get that gunk on me. Okay. I'm going to switch over to just a regular wipe. Not so much for scrubbing as I'm trying to get all the little bits that are going sideways and getting on other areas of the board. So I don't want to leave any of that there. I mean, it's not conductive. It wouldn't hurt anything, but ew. I don't care that it's not going to bridge anything. It's not going to interfere with airflow. It's like the principle of the thing. Yeah, squeaky, squeaky. And I just want my last wipe to come away without any black dots. We're getting there. It's a Kimtech wipe. And as I'm doing this, this is on my ESD mat, and my wrist is constantly touching the metal of the case, which is touching my ESD mat. And then what I'm doing here is I'm starting past the edge of the pad and I'm wiping towards it, basically as a cleaning method of preventing the spread of those little dots. Here we have one. So I'm going to fold this over. Circular scrub. Wipe around the outside. Okay, we got it. Some drying. Now we have our replacement little dot. And I stabbed it with this just to get the separation started. Yep, nice and sticky. There we go. All good. Okay, so I've pulled the known good power supply from the otherwise good but like different kind of opening and different mod of the 81A, and I have it plugged in but not installed in my prior parts donor that just had a bad power supply. So the first thing before we put any more work into this like Frankenstein operation to make the best version of 2 is to make certain, confirming with this good power supply, that this turns on, that it measures frequency. It won't be terribly accurate. We haven't moved the time base over yet, but we just want a basic function sanity check after making sure, will this power on? We have a power supply that is largely unshielded. It's the bottom of that is all metal with standoff, so it's not like shorting anything by sitting like this. Don't do this at home, kids. Like open stuff over here, so be careful if you're doing something like this, where you're touching when you go to plug in, or plug in here first while your other end is unplugged. Fan started running right away. That's normal because with these, the power supply is always on, which is kind of stupid because ideally they would have engineered it so that it was only on when it has a time base installed. The whole reason for it always being on is to keep the time base heated, but oh well. Self-test pass. Okay, the VFD is definitely dim, so we're going to be taking the better VFD from that, because all of the mod stuff, like the differences in the EEPROM and the 0-ohm resistor, they're all on the measurement board, not the display/controller board. We needed to swap some of that anyway because well, we would have needed to swap that if we were using this as the main unit, because that one has one of the buttons, I think the trigger button, that's like cut off. But before we go any further, we will feed it 10 megahertz and just make sure it gives us a close reading. This is going off of the onboard time base, which is pretty much garbage. It's not ovenized. It's not like its specs are like 10 to the -5 or something. They're bad. But as long as it gets like 9 to 11 megahertz, you're good in terms of a function check. From my GPSDO 10 megahertz reference. Yeah, okay. Measurement board is good. Channel 1 receiving is good. So we are okay to proceed. And obviously there's a bunch of crap to clean off, but making sure that transferring the stuff we wanted to transfer was going to work came before like investing the time to detail clean everything. Sweet. I think I'm just going to combine these videos into a general how to disassemble, reassemble, refurbish / service the 531X1A frequency counter series. So what I'm doing right now is swapping part of the front panel, and I'm actually going to take the front panel apart because I want the good VFD from there and the good membrane buttons from here, because one of the buttons is sheared off on that membrane button strip. So to get the best of all pieces to make the best possible version of a counter. So to take this off, you have some Torx screws on the side. Those are T20 Torx. Typically there'll be 4, 1, 2, and then same on the opposite side. You pop out this ribbon cable from right here, and it just has these press to release things. Nice. Then you want to unscrew this. This can be a little tricky. If you have the appropriate deep socket, that the front of it isn't chamfered, because it's a very shallow amount of nut to latch onto. But if you have a deep socket that will hold it, that's the best tool for the job. Otherwise, you can use Knipex pliers wrenches, specifically these and the knockoffs of them, I guess, because the jaws stay parallel. And what you want to do is size it appropriately. And this is very thin metal. This will bend easily. So what you don't want to do is grip it and then grip hard. You want to use the absolute minimum amount of force to hold it to turn, because if you start gripping down, you're compressing this onto the threads, and you're damaging this as well as making it stuck harder, because you're basically crimping it down onto those threads, which you don't want to do. So least amount of force and just turn. And if it's fighting you, if you're not getting it and you feel like you have to grip harder, don't grip harder. Find the better tool for the job. Get a proper deep well socket that will fit it and use that instead. So once you have that off and that disconnected and those screws out, you press this down. So it starts out popped into place like this. So you just press to release. A lot of this era gear has the front panel attached in such a manner. Then repeat for the opposite side. And this top side is easier to get than the bottom side because the bottom side has this ridge on this side. So you press here down and you pull this up. You want to get just enough to pop it off. And there's your front panel. And then we'll go ahead and take this apart so I can pull the membrane buttons out of this. I guess I can make this one whole segment. Let's move this over here. Yeah, it's going to take a lot of cleaning. So from here, these just have, I don't think there's actually screws on the first part. So you have some little plastic clips that it just slides plastic, it clicks into place. So you want to pry gently to get the board off of 1, 2, 3, 4, 5. Now, given we have fewer on the top and we have more spaces to get a hold of it on top, it's better to have your flexing action up here and then rotate it up, and then you can just slide a little bit once it's off of these indexing stands. Let's see. We can try with a plastic spudger, and if we need something more substantial, we can go up from there. All right, I think we're going to need 2. So I'm going to use 1 for prying and 1 to kind of wedge in place to keep that that gap open without over compressing on the plastic and maybe cracking the faceplate, which we don't want to do. Is this? I'm going to pause to reposition. All right, that's a much better view. So I'm gently prying here to make a little room here. And yeah, okay. Oops, sorry about that. So now we are past that latch. That's off. And we don't want to apply any more pressure than need be. So we're going to switch over to this one. Let's see. And we have that free. So now we're going to see if we can just pull straight out. No, we will need to repeat the procedure on the opposite side, but that should be a lot easier now that we've basically released tension from it. So let's go ahead and do this side. And we already have, because this is at an angle, we already have a much bigger gap, so just push this in here, get right next to it. Gentle. Gentle. It's kind of nerve-wracking. And there's a ringing sound. That's the filaments in the VFD vibrating. Yeah. Looks like the plastic deformed on that last latch a bit. Yeah. Yeah, we dinged that that last bit right there. That'll be okay though. So we have two different sets of membrane buttons. And fortunately for these counters, I've never once, and I've serviced and sold a lot of these, I've never once encountered these membrane buttons from Hewlett-Packard or Agilent or Keysight in this series of counter failing conductivity. Like basically when you press a button, the button doesn't press, or you have to like press hard and wiggle. So I'm guessing whatever formulation of making the rubber conductive they use on these, they did good engineering for the long term. So good on them. So on that one, this plastic right here is sheared off, and this part is fine. So we're going to leave that there since we don't need to swap it, since this is a two-part, and we'll pull this and swap it from there. As well as just swapping this whole board because the VFD is dim. There are ways to rejuvenate a VFD, and they're kind of hit or miss in terms of success. But it can be done. It's basically applying reversed voltage along the filaments to pull carbon buildup off. I believe that's the principle behind it. But yeah, we're not going to worry about it here since we have a known nice bright one there. That or Dimog. He is on EEV blog and eBay, and he has his own website, hubequip.net. He's made an LED version of this with a very, very nice, comprehensive instruction booklet that you can just buy, and you desolder it, and you solder the new one in with a couple bodge wires for power supply. It's very well done. All right, so I'm going to stop this portion here, and then I'll repeat the same over there. Oh, and something else. On these power supplies, look what I found. That's another one. It looks like the same formulation of rubber, so we are going to get rid of that and replace it too. I'm pretty sure I have the exact same size as that in my stocks. So yeah, we're going to pull that and replace it. Quick addendum to removing the front panel. So that one that I've disassembled had screws along here. So that meant it was previously rack mounted, and it wasn't like this middle screw wasn't present. If they haven't been rack mounted, you'll see a single screw here in the center and on the other side, and that's what you remove instead of these two. Otherwise the same. Another minor addendum, and this is for cleaning these frequency counters, or basically all HPAK gear that is this form factor and has this smoked like Lexan or Perspex cover. I don't know if they ever changed it to make this not happen, because once I understood what was happening, I stopped. Do not use alcohol wipes or any form of alcohol at all to clean this. Don't ever do it. What happens is, I don't know the exact mechanism of action, but the effect is that it creates a cloudy, non-clear layer on the surface. And it's like, it kind of comes across as this dust. Like, you can clean it. You can take a Kimtech wipe and wipe it, and it looks fine. And then moments after, it becomes cloudy again. It's not like you take water and scrub it, and then the water fills in tiny micro scratches until it dries off, and that's the effect. No, it's some kind of chemical reaction between alcohol and this smoked perspex that causes this. And if you do that, then you literally have to go through a tedious polishing compound process to polish off and remove like a micron or so of the surface of this plastic to fix it. It's a pain in the ass. So instead of, like, you can use alcohol for all the rest of this. On some of the oldest ones, like the oldest of the 34401As, you want to be careful of the silk screen printing, because that can fade as well. Newer ones, in my experience, don't have that issue. But yeah, this specifically, don't clean with alcohol. Just use paper towel and water, or paper towel, water, and just hand soap, and then dry afterwards. And that's what you want to do with this. Okay. We're just encountering all sorts of different things happening here, which is not bad from an informational perspective. So when I pulled this off, I noticed this. This is a little plastic indexing rod that goes through there and also fixes the position of the screen. It had broken off during the removal process, because plastic can get brittle over time. So you can see it's right there. So how do you put this back on so that it will have mechanical soundness? The first thing I can tell you is that super glue is the wrong tool for the job, and it'll just break. The bond will not be good enough. I've learned time and time again, super glue is just no good for these purposes. So there are epoxies. Like, the best are 24-hour cure epoxies, and those are very, very effective. But I don't want to wait 24 hours for this, so what else do we have? Well, something you can do, let me go and, I'm going to pause this for a sec. So this is just one method, but there are these little micro drills, and they're twist drills. You drill by hand. So what I can do is I can put this in a little, like a pin vise or something similar to this, or something to hold it gently, and I can drill down the center of it. And I can do the same in the center of that. And then I just cut off a length of, it's basically spring steel. Length is more than enough. And in combination with UV curing solder mask, which is very strong at bonding these plastics in my experience. So I put the solder mask on the surfaces. I and kind of paint it around the edges thinly, because you don't want to create large ridges that will like catch on things and make it difficult to reassemble. And that's your epoxy. And then this little pin down the center serves as a reinforcing strength member. And you're good. And then you want to press the metal in past the top of this right here. So you want to drill in further than what you're cutting out, and you can just use the cutout or the cut off edge remainder of this to push it in further, because you don't want exposed metal. And then you put a little bit more of UV curing solder mask on the top to seal it, and you're good. You have a combination epoxy bond and basically the micro equivalent of rebar reinforced in your, in this metaphor, concrete. Depending on how far you want to go with a refurb on this, a common thing to find is the plastic on this tends to get dinged from impacts, and you encounter, plastic deformation. There are so many uses for these nice, smooth Knipex pliers wrenches, just for the fact that the surfaces are non-marring. They're flat, smooth, soft metal, and they're always parallel. So here we have a tiny little ding, and it sticks out past the edge. And you can gently, just going a little bit at a time and gradually doing a little bit more, just like that. It won't be perfect, but you can reduce it, and you can make it largely flat along here, better than it was before. Not perfect. It's still evident that they got dinged there, but you can flatten it down. So you can still see where the ding is, but it's no longer protruding outwards. Like right there, you can see a tiny divot there. And there is, I'm not sure if it's actually going to be visible in the video or not, there is a much less visible, basically shinier instead of matte area of the plastic there, because it got, squished by metal. So you can kind of barely visually see where the defect was from the front. But yeah, it's better than it was. And it's a way to further restore these instruments, depending on how far you want to go for cosmetics. So, as I was washing this, I spent some time looking at this, and I was wondering, what am I looking at? And I realized what this was Hewlett-Packard / Agilent solution to RF shielded plastic. This is particleized copper embedded into the plastic injection mold of the front faceplate. How cool is that? So that's why it's copper colored, because it's copper. It's literally copper powder embedded into the injection mold. Sweet. Oh, and for cleaning, if you need to get So there's some scuffs, and at that point, if you have scuffs, basically you need a nice ultrafine polishing compound. That's the solution for that. But if you have stickers that were on there and sticker residue is there, because I mentioned you can't use alcohol. So you can, once you have all the circuits out, you can just take this and you can take it to your sink and wash it with hot water and soap, and it's perfectly fine to do. You want to dry it because this whole thing is a adhesive stick-on applique, and in the back here is kind of access to that. So you want to be pretty thorough in the drying, and one of these air bulbs that you use to clean microscope optics, they're really great for getting all the little crevices around there and making sure that every little bit of water is out. Like there's still a little bit in here, so it takes a few passes. That, or I can use my hot air station just at a good, remove, so it's only warm, like nothing I couldn't leave in front of my fingers and keep at that distance without hurting myself. But you can use that as well to gradually warm it up and evaporate off the little bit that's left of the water. And then it's nice and clean. So for sticker residue on this, yeah, just soap, gently scrub with your hands, and you can kind of get it to stick to your skin more than this, and then you just wash your hands. And for another way to do it, or your final pass, is so long as you don't have stuff that's like really coarse and scratchy, just take some toilet paper, like 3 squares of toilet paper, wet it, run that wetted surface over hand soap, like a bar of hand soap, and then gently, circular motions, go over this and get the remaining bit of sticker residue to unbond, and literally rinse and repeat. It takes patience because, yeah, if you scrubbed hard, you could go faster, but you don't want to scratch stuff up. So that's one way to do that and get this clean without harming it. Very cool. So one of the things to do when doing like comprehensive maintenance on these is washing the membrane buttons. Not the back here. HPAK gear doesn't ever seem to need that. But, these, where humans can touch them, tend to get dirty. We actually still have... There's some of the like particleized copper that's embedded in there, but no longer really dirty. So these are really simple. Like, I wanted to check and make sure. And these are stubs for areas that don't actually have buttons. So I washed one of these first. Like, I measured a bunch of them. They're all basically between 100 ohms and 200 ohms. So I washed here, like rubbing like this and like this under hot water. No soap needed. This got wet, but I didn't I at no point was scrubbing on these conductive surfaces. And then to dry them, I just took some toilet paper and just dabbed. Again, no scrubbing, just dabbed to soak up the water. And then on my sink surface, all I had to do was that a few times, wipe up the water, and after like 3 or 4 times, it's just dry. The water just, sheds off it. So I rechecked. The resistance did not change. So if you're at least gentle as described, then washing these is not a problem. Again, that was just hot water and manual action on like the surface of the buttons and the sides. And that cleaned off the basically schmutz and dirt from people, pressing a button over and over with not necessarily cleanest hands. So this is just a neat difference that I saw and wanted to catch on video. Here we have the front panel that we've already seen. That's the normal front panel. And here is a different version of it. A different implementation of the metallized plastic. That's from the one that had the 5 gigahertz module in it. So that one pretty clearly has particleized copper, and this is more smooth. I guess during the years, they're both Agilent branded. So that was what, from 99 until whenever they changed to Keysight? So it looks like they changed the metallization process, and it also looks like it's not copper, but something else. I don't know, maybe aluminum impregnation? But it's not particleized. So kind of neat. I just wanted to add it to the video. Okay, so this is before I reassemble. These were both Agilent branded, but they were still made in different years, and we do have different part iteration numbers. So what I'm going to do is, so I'll set this back here and let's get something to sit in front of it so it doesn't slide forward again. So I'm going to plug this in. Things are connected now, just not reassembled, and I want to make sure that it boots properly. That's about it. Oh, and then that I can use the front panel, which I can do just by touching anything conductive to the pads, make sure it responds. All right, other end of this is unplugged. Okay. Hey, Foof. So far, so good. Let's see. Okay, so this right here is gate, time, it's kind of rounded so it's not making perfect contact. Oh, and then yeah, I need something better to contact. Yeah, the back of that is smooth. Debounce is really difficult with this. All right. Yeah. And then that one is enter. Mm. Okay. All right. Yeah. Controls respond. Okay. So I'm now at the point that things are tested. The components are going to work together, and I want to get that bit right there fixed. So I used the pin vise drills. I used my Mitutoyo caliper to measure out the diameter of the safety pin steel, and then I tried to match as best as I could the closest pin vise drill. And then, of course, because they're consumables and they're really delicate, I snapped one off inside, but there was enough clearance to still get this in. I drilled a tiny little hole there. Yeah, that'll do. So the way to work with this UV curing solder mask is to use like layers and work your way outward. So what I'm going to do here is I'm going to put some in there and then push this onto it and then cure all around the outside. And then I'll put a little more around the edge of the joint and cure again. And to match as best as I can, like I got a bunch of different of these colors. So this Relife 3-second cure is very, very good. I'm in a community of like YouTuber repair people for electronics, and a lot of us have tried a lot of different stuff, and this comes out as one of the better ones. So you want to take this and put it away from where it'll be exposed to UV. That screws on. And then we may need to waste a bit, just like you would with, like if you're spray painting, you want to waste the first little bit. Basically, some of the first stuff that can come out can be separated or bad, so you want to test it first. See a flash in there, so it's in the tube. Okay, that doesn't look separated. We're good. If it's separated, it'll basically look like a thin, translucent oil. Okay. So I have the tip of that covered up so that UV doesn't make its own way on the tip. That gets super annoying if it happens. And It's a very small amount exposed. I'm going to clean this up a teeny bit. So when you're shaping this solder mask, basically it's UV curing epoxy. You want stuff with a very fine tip. So these are the smaller of the clean room swabs that I keep in stock. And, 1 second, I'm going to pause. Okay, I just paused so you wouldn't have the evil creak sound when I move this thing. Okay. I want to try to get this as straight as I can. That looks right. Okay. And then once you have that, like, just toss it. Don't try to Scrooge McDuck your consumables. And I'm actually doing this through my camera. That way I can see what I'm doing, but I'm not, directly looking into the ultraviolet. All right, let's get a little feel for that. That's solid. I'm being gentle with it, of course, but it's solid. So let's do another pass. And sorry about that. So this time we'll use this to apply, and we'll put another layer on. A little bit more. Oh, this dispenser tool is so much better than the last one I had. You have so much more fine control of it. The other one was this ratcheting thing, and it was constantly pumping out more than needed. And with this stuff, a little goes a long way. That's good for a second layer. I don't know if we'll need a third. I'll take a look after. But I'm guessing we probably won't. Darn you, Kimtech wipes. The box of them, like, has the top one fall back in sometimes. Then I have to go and try to get it to dispense again. And it never seems to work properly. Oh, and for a solder mask and the like, there are these super useful little things. They're just silicone nubs. Let's see if this is the right size. No, that's the tiny one. Where are the larger ones? I'm going to pause. 1 sec. There they are. Ah, no, don't rip. Damn you, solder mask. You set it on its side, it starts to ooze out. Okay, so what these are is they're just handy little silicone caps. Super cheap. Grr. Stop. Alright, we're gonna have to be quick. Yeah. There. Leak no more. Well, ooze out no more. And then you can store it per normal and not worry about it leaking. So that'll go in my active in-use stuff drawer for soldering. And now it doesn't matter if it's like straight pointed up or if it's sideways or pointed down, it just won't leak out. I think it was, I don't know, probably less than $1 for 50 of these on AliExpress. Yeah. Handy to have for solder mask, for flux, for solder paste, if you have the kind that comes out of a syringe. Very handy. All right, so we'll go ahead and cure this again. And I'm like hiding behind the camera with my face right up to it so I can see what I'm doing, but I'm not like exposing my eyes to UV. I'm getting some on my skin, but 15 seconds worth on my skin is not a big deal. Yeah. All right, so we have a spring steel rod down the center. And because of how the thingy broke off, I had meant to have it as a through hole, like all the way through, but that's basically hollow, so there's no exposed metal. But yeah, all fixed. And now it has a little steel core inside of it, so it can flex around and it won't just snap by being brittle plastic. And now we can reassemble. Okay, we have the front panel reassembled. What I found works well is once you have the little posts indexed and it's pushed down to the point where it's stopped at these little snap-in tabs, is you want to be pressing on the board in a couple different places to even out pressure. You take a flat spudger and you pry enough that it can slip past it, but you want to maintain the downward pressure evenly across the board so that the board doesn't go like this. And that's about it. You go one to the next, and then it pops in. And you just be patient, wiggle, just take your time so that you don't pry further than you need to, and you're good. Okay, we just pulled the ovenized oscillator from the unit that had the 5 gigahertz module. And this is what it looks like. It's just held on by 3 Torx screws. It's basically the driver board for the oscillator. And then you'll notice along here, that's an old, like ISA width style, just board connector. They've been using this same oscillator design. Well, I think the current generation of frequency counters has an updated design, but this has worked well for many, many decades. So by their schema, this doesn't apply to everything HPAK, but a lot. You take the first 2 numbers of the serial number and add it to 1960, and that gives you the year it was made. So this is US 20. So this was made in 1980. It is a 45-year-old crystal oscillator. And when I had that one turned on, after a short warm-up period, it was dead on, like 10 megahertz, like 10,000,000,000.01, with the 1 fluctuating between 1 and 0. No calibration. It had been sitting on my shelf. Sitting on my shelf for a long time. Yeah. They kept the design for a reason. Okay, we have our ovenized oscillator installed. With these 3 little Torx screws up here, you just tighten them to like a firm finger tight. You don't need to go beyond that. You can just go over each one twice after you've tightened all 3 once. Something of note, so you can see like this, it looks like, what is all the smuts? This is normal for the metal that Hewlett-Packard and then Agilent have used for the frames. They weren't really worried about some degree of oxidation. It's not really rust, it forms a patina. And I've previously tried different methods of cleaning it, and like I scrub it with alcohol swabs or what have you. I've fully disassembled these things before and just washed them with soap and water first before detail scrubbing. It doesn't remove the patina. Or you can remove a layer and then another oxidation layer will form, and it just looks like that. Different ones will have different amounts of it, and some won't look like that much at all. Like here we have this other one. Let's move this over here. And this looks more like oil sheen. That's kind of this warm reddish purplish rainbow effect. But yeah, it's just the nature of the metal they chose for this frame. So not really something you need to worry about. It's not a sign of it having been like exposed to water or having been in a basement that flooded or something like that. It's on like all of them to varying different expressions and extents. Oh, and I would like to say a note on the power supply, specifically the fan. So The main way that these units can die, and the reason that I had one already sitting around as a parts unit, is the power supply is always on. So the fan is always running, and on the later units it's always running on low, like even when it's otherwise powered off. And that's so the power supply can provide power for the oscillator to keep the oven warm and keep it oscillating. Because the ovenized crystal oscillators become more stable over consecutive power on hours. So if you have like 1,000 hours on, 1,000 hours off, 1,000 hours on, they are less stable than as if you had them on for just 2,000 consecutive power on hours. In terms of if you get into the territory of time nuts, it's the same expression as volt nut, except chasing ever more and more precision about time, then these oscillators, from that extreme perspective, they don't like being turned off, cooling down, turned back on, and going through power cycles. Because what you get from that is a teeny bit of drift. It's not really a problem. If you have an exterior 10 megahertz source like a GPSDO, you can just recalibrate it. And over time, like over thousands of power on hours, the effect gets less and less and less. And like I said, when that one was on without me calling it, it was dead on. And that's not necessarily a matter of the oscillator being perfect, but the oscillator being stable and then a specific offset number being saved on the device. And that's your calibration factor for how much offset of frequency do I need to make that 10 megahertz true 10 megahertz. So we'll definitely need to calibrate this. I'm curious to see how much it will show off by, because it hadn't had an oscillator in it. Oh wait, no, this did originally have an oscillator in it, and I had harvested it, and now it's getting another one. So it'll be off by whatever the difference of the calibration factors was between when this previously had an oscillator and the new one that I'm putting in now. And I'm getting off topic. Power supplies. My mind wanders, apologies. I hate noise. It is a sensory issue for me. A lot of neuroatypical people, or neurodivergent people, or individuals on the autism spectrum have sensory issues. And for me, noise is one of them. So, I'm going to pause for a second. Over here, that bottom switch is labeled 53132A. And my frequency counter is up on the second shelf. And I just leave it powered off. Because even though I've cleaned the fan, it still produces some noise. And for me, every tiny bit of constant noise really needs to be justified. Like, extremely so. The one thing that I would tolerate being on all the time is my Keysight Black Era 3458A to keep the voltage reference hot. I wouldn't even stand to keep all of the 3458As turned on. I did recently buy Noctua fans, and it's on the list of projects to swap out those fans, but that's both digressing and related. You can get a 40 millimeter by 20 millimeter Noctua fan. You want the 12 volt version. It doesn't matter if you get the pulse width modulated or the non-pulse width modulated. The PWM version, you just don't use that wire. That's all you have to do. And you can straight replace this with the Noctua. The pressure and airflow profiles are not identical. It is a little bit less airflow. But I have spoken with multiple people who have done this mod and had it always on for 2 years. Like, one person was 1 year, another was 2+ years. I feel it's enough data that I can comfortably say you're safe to do it. You're not going to burn out your power supply. What burns out your power supplies are basically immense amounts of dust insulating everything, and or the fan getting clogged with dust to the point that it fails, or just fan normal mean time before failure, you drew the short straw and it failed. And that's what kills these power supplies. So the Noctua fan, you can get it. It's like $16 on Amazon. The majority of the ones on eBay are like 20, 21 bucks, and 99 out of 100 of those are sellers that are drop shipping from Amazon Prime accounts and just pocketing the difference. So, as much as I don't like recommending stuff on Amazon, currently the best price is there at $15.95. And yeah, you just, it is direct connected, so you snip, connect red, connect black, put it in. They come with these nifty little silicone mounts so that it's even more vibration reduction. Use them, and you can have a is it running? Is it turned on? Level of sound. It's beautiful. And on my to-do list for materials purchases is I've been watching for any eBay seller who has like a bunch of them that they get from somewhere, and I just want to buy them all cheap so I can do this mod on. I have a bunch of these counters. They're very popular, and for good reason. They're good counters. And I want to do that mod to every last one of them because I know I'm not the only one out there who cares about it. All right. Okay, I have it all internally assembled. I just don't have the, case on yet. And we're going to do one final power on check. And I'm curious to see what it tells us for however inaccurate it'll be for frequency until I cal it. So there we go. Good VFD. Self-test pass. So it is starting from cold, pretty much. So it's not really a big surprise. I'm kind of randomly curious how close it will be to 10 megahertz. Obviously, it's in the process of warming up the oven. And this won't be perfect because the shell is off, but it will be pretty close. It's not like I have a breeze here in my lab, so the air is pretty still. But yeah, functional. So let's go to gate, time. Let's go to 1 second gate. And that gives you your extra digits, although I'm not sure how accurate the last couple of digits are on the 81A compared to like the 32A when you go to 1 second gate time. I know the 31A is a 10-digit counter while the 32A is a 12-digit counter. I think this is a 10-digit class. Let's see. 2, 3, 4, 5, 6, 10. Yeah, 10-digit. Okay. So, yeah, we have 10 megahertz, 100 or thousands, and then we have a resolution down to the 1 millihertz. All right, I'm not gonna make you like watch it warm up, so I'm gonna stop the video here. I might leave it running for a little bit just to watch it, but I won't calibrate it until I have it fully assembled with the shell on, and then let it warm up until I see it stabilize. Once I see it stabilize and not fluctuate continuously in one direction, then it's ready for calibration. Okay, I've been leaving it while I did other stuff, like made... Dinner seems like the wrong word at 2 a.m., but whatever. Foods. Well, I made and ate foods. and it's averaged down by 30 millihertz. So it is still very further gradually stabilizing, uh, which means it's not fully reached its stabilization point. I'm kind of rambling because, 2 a.m. Anyway, now that I've finished eating, I'm going to get the shell on this and let it warm up. And yeah, we'll see where it stabilizes and stops drifting down. Because it's been drifting towards like true 10 megahertz, so that's pretty promising. Maybe where it stores the calibration offset for the time base is on the time base board, which would kind of make sense. And if so, that's cool. Alright, so I'm just finishing up this refurb, and last thing is basically a pretty normal issue with this generation of HPAK gear. One thing they didn't design as well as they could have is this rear bezel. So if you look down there, this isn't tight. Watch what happens when I tighten it. See how it's bowed? That's a problem with these bezels, and they usually fail in the same spot because of that. And indeed, that one right there is, and you can see it like this. So, as this is a common issue, one of my EEV blog friends, Dimog, has come up with a solution to this. He has taken the time to refine a very good 3D printed replacement, which I buy like 10 of them at a time. And he also includes the proper screws, the retained screws, already in there, made with PETG. Great stuff. So this isn't too badly broken. I suppose it's not impossible to repair these if you have to, but I haven't found a way yet that works. You'd probably be looking at like a fiberglass method, like trying to lay down, like maybe shave in a channel to lay down Kevlar fibers and use some UV curing epoxy to get it in there, and maybe getting pins, or I don't know, something with a lot of teeth to grip into each of these sides to compress down. It would be convoluted. It would be convoluted to get something that would work and endure the pressure of being clipped in there. So we have our 3D printed replacement. Let's see. I believe there is a top and a bottom. Yeah, because we have this, or that could be there for compatibility with another device. Let me see. Yeah. It's for that right there, I believe. That little notch in there. So when you're putting these in, basically watch for when it starts to bow. Then push the sides firmly, wiggle them to make sure they're fully seated. Back it out. I'm going to pause for a second. Okay, it's been like a second later. I've repositioned. So watch this line. So we've backed out a bit. Going to screw in again. It's a little bowed. I think the wiggling helped. I'm going to double check that afterwards. Let's try the other side. Did I snap plastic or did it just snap into place? We'll need to check that. Sorry for the noise. Okay, so you can still see the bowing effect if you over tighten. I'm going to pull this out just to inspect it, because I want to see if I snapped it into place or if I snapped it, because, you know, they're cheap. I can put another one in if need be. Now let's pause. Okay, no need to make you endure that noise a second time. Loosen this a little. See no cracks there. What about all of these posts? Did any of them crack? I haven't broken one of these before, but there's always a first time. No. No, it looks like that was just the sound of it popping into place. Alright, that's fine. So let's line up that, Alright, we moved it upside down, so that's right there. Okay, yeah, I can hear that clicking just by pushing it in by hand. Good. Okay, Okay, so this should, yeah, there we go. That's good. So what you want to look for is right along there. I'm going to tighten it. And you see how it's touching there and not there? So it's not going to be fully tight. You want to back it out until that line is at least very close to consistent. It won't be fully tightened, but these tend to not come out, especially when the screw down here gets tightened. Then they're pretty secure. But it's better to have these just a little bit loose than to have that constant stress. Now, this is PET-G, so these are pretty new products, so we don't have like a test of these being in service for like 20 years to find out what happens with them. But, you know, figure if you're leaving it under stress, it's going to be enduring more forces than if you don't leave it under stress. There's touching. Let's give it a little wiggle, see if anything can pop a little bit further into place. No? Okay. And then let's go ahead and back it out until we see a consistent line. And yeah. Let's double check the other side. Might want to back this one out a little bit more. Yeah, just a tad. Okay. So that's where you want them. So when you have an original bezel and it's not damaged, you want to basically watch that line while you're putting it in, and don't push all the way in, because all of these are pretty old by now. They'll be like on the scale of 20 to 30 years old. So you want to watch, and when you start to see that line turn into a curve, stop and then back it out. Don't put it all the way in. Like these new PET-G panels, it's fine for me to flex them a little to push in and then back them out. With the original ones, take care not to flex them too much. Otherwise, where is it? Yeah. Otherwise that. Okay. Okay. Looks like it's fully warmed up. It's been flickering between like 270 and 290 millihertz at the end there. So we're going to proceed with calibration. And we're going to have the visual tag along for calibration as well, just because it's fun to see information. Okay. So this is another feed off my distribution amplifier for my GPSDO. So that'll be a clean 10 megahertz. And then this one is going to go into the 10 megahertz reference output from this. So that will be directly representing the frequency output from the oscillator. So that shift represents the drift difference in frequency between yellow, which we're triggered and locked on, which is our 10 megahertz true output, and blue, which is basically, I was going to say a third of a hertz, roughly, between a third and a fourth of a hertz. About 280 millihertz off from 10 megahertz. So we'll turn this off. We'll go and hold down recall and turn it on. And that gives us our version number. We're in utilities now. Time base, auto. Oh, sorry, that was to get to utility and those menus. That's not for calibration. So let's power off. I believe it is actually... It's been a bit since I did one of these. I believe it's scale offset you hold and then power on. Cal secure. So the code is, I believe it's just 53131 because that was like the main one in the series. I'm going to quick look it up. It might be 81, but maybe not. One second. Okay, it looks like it should be 53181 to match the model. So we just use the arrows to change the number. So there we have 53181, and let's see if it works. And now we have cal unsecure. So we are unlocked and we are now able to perform calibration. And then specifically the one we're doing is cal time base. That's our frequency reference. Hey, pretty. He'll come over here, and if I'm not paying attention, he'll like sit on my keyboard to make it screw up. Yeah. And when he does that, even after I move it, he'll then roll over and flop down onto the keyboard because he knows that it'll get me to come over here. Hey, jackass. Who's very lovey and manipulative. I'm busy right now. You will survive. It's like, no, I won't. I'm so lonely. You only pet me 70,000 or 1,000 times a day. Ugh. Okay. So, cal time base. We'll go enter. It's asking us to supply 10 megahertz. I'm just going to let it scroll so you can see it to channel 1. Yep. And then press enter. Yep. So we'll press enter. And calibration has begun. It's pretty much automatic from this point. And this is us getting to see the adjustments happening, the back and forth frequency. And even though it seems much closer now, it's going to go all over the place for a while as it goes through calibration. And eventually it'll lock. But I'll leave this recording, so this is part of the video. Hey, kitty. He is such a soft cat. Looks pretty close. It doesn't mean it'll stop here, though. Oh, you want up here? Okay. You can be there. That's fine. Who likes to destructively nuzzle my stuff and threaten to knock it over unless he's being pet? You do. And it might finish here, or it might resume shifting stuff. It depends how it's feeling. And the calibration never really worries about, like, ending up phase matched, just frequency matched. He nuzzles. Who's very affectionate. And Floofy approves. The time base has passed calibration. Floofy, say hi. Yeah. Okay. Oh, whiner. So, yeah, it's probably the easiest device to calibrate, at least that part of it. There's a lot of other functions that go into calibrating all the different features, but the time base is the big one, and that is by far the easiest cal that I've ever come across of all the stuff that I've worked on. Alright, so you can't just like press enter and get out of this. You have to reboot. So off, and the time base stays on. The 10 megahertz out stays on. So let's turn it back on. And now we're going to ask it what it reads off this GPSDO. Yeah. 10 megahertz, solid. Now, if you pay attention to this, and if we wait long enough, we'll probably be able to see phase shift happen very, very gradually. Like I'm watching over here the 0 point of the waveform as it passes the 10 megahertz ref. So at that rate, it's probably off by maybe 1 millihertz, 1/100th of a hertz or less. So let's change the gate time. It's currently at 100 milliseconds. So let's go gate time, and let's change it to 10 seconds. Go back to frequency 1. Yeah, there we go. So we briefly saw, 1 millihertz. So that means since it's flickering back and forth on 1 millihertz, it's off in terms of how finely it's calibrated by a little bit below 1 millihertz, which is excellent. It's really, really good. So that's it. We're done. This is ready to go.